Welcome to our educational video about the formation of the solar system. Today, we'll explore the fascinating journey that began 4.6 billion years ago and led to the planetary system we live in today. The most widely accepted theory for the formation of our solar system is called the nebular hypothesis. This theory suggests that our solar system formed from a giant cloud of gas and dust in space. Let's begin our story about 4.6 billion years ago. Our solar system started as a giant, slowly rotating cloud of gas and dust called a solar nebula. This nebula was primarily composed of hydrogen and helium, with small amounts of heavier elements like carbon, oxygen, and silicon. Step 2, the collapse of the nebula. At some point, a disturbance, possibly a shock wave from a nearby supernova, caused the nebula to begin collapsing under its own gravity. As the cloud collapsed, it began spinning faster and faster due to the conservation of angular momentum, the same principle that makes ice skaters spin faster when they pull in their arms. This faster rotation caused the cloud to flatten into a disk shape, with most of the mass concentrating in the center. Step 3, formation of the sun. As material continued to fall toward the center of the disk, a dense, hot core called a protostar formed. The increasing pressure and temperature at the center of this protostar eventually became so intense that nuclear fusion began. Hydrogen atoms started fusing together to form helium, releasing enormous amounts of energy in the process. This marked the birth of our sun about 4.6 billion years ago. Step 4, formation of planetesimals. Meanwhile, in the remaining disk of dust and gas orbiting around the young sun, tiny particles began to stick together. Dust particles collided and adhered due to electrostatic forces, similar to how static electricity makes dust stick to surfaces. These growing clumps formed planetesimals, small, solid objects ranging from a few meters to several kilometers in size. The composition of these planetesimals varied depending on their distance from the sun. Step 5, formation of protoplanets. Over time, these planetesimals continued to collide and merge, forming larger bodies called protoplanets. This process, known as accretion, was driven by gravitational attraction. As objects grew larger, their gravity increased, allowing them to attract and capture more material. Eventually, the largest protoplanets began clearing their orbital paths of smaller objects, either by collision or gravitational deflection. Step 6, differentiation of the solar system. As the protoplanets grew, a clear distinction emerged between the inner and outer regions of the solar system. In the inner solar system, close to the sun, it was too hot for volatile substances like water and gases to remain solid. This led to the formation of the 4 terrestrial or rocky planets: Mercury, Venus, Earth, and Mars. In the outer solar system, beyond what's known as the frost line, it was cold enough for ices and gases to condense. This allowed the outer planets to grow much larger, forming the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Step 7, clearing the nebula. As the young sun reached its full strength, it began emitting a powerful solar wind, a stream of charged particles that swept away much of the remaining gas and dust from the solar system. This left behind the planets, moons, and smaller bodies we see today, orbiting in relatively empty space. Step 8, final stages and current solar system. Over millions of years, the remaining objects settled into stable orbits. The leftover planetesimals that didn't become part of planets became asteroids, primarily in the asteroid belt between Mars and Jupiter, and comets, mostly in the distant Kuiper belt and Oort cloud. And that brings us to our current solar system, a star with 8 planets, various dwarf planets, and countless smaller objects, all formed from a single cloud of gas and dust over 4.6 billion years ages. To summarize what we've learned about the formation of our solar system, it began as a giant cloud of gas and dust. This cloud collapsed and formed a spinning disk with a protostar at its center. The protostar ignited fusion reactions and became our sun. Around the sun, dust particles stuck together to form planetesimals. These planetesimals collided and grew to become protoplanets. The inner protoplanets formed the rocky planets, while the outer ones became gas and ice giants. The solar wind cleared away remaining gas and dust, and finally, leftover planetesimals became asteroids and comets. Thank you for watching this explanation of how our solar system formed. Understanding our cosmic origins helps us appreciate the incredible journey that led to the world we live in today.